everyone, Varuna here, and welcome to another KTaNE module tutorial. This time I'll be covering Turing Machine Nightmare. If you're familiar with the module Turing Machine, this module should not really be a problem to you. However, if you do not know the module, don't worry, I'll explain it here. This module contains 6 letters and 6 lettered buttons and 5 number buttons, and as well as 3 different displays. In this module, if you press a display, you'll be given a clue. These clues give out hints to what a solution to what the solution to the module is. So these cycle on this module. It will cycle through 6 clues because there are 6 letters here. So we have this clue here, which is square plus circle is either less than, equal to, or more than 4. So if you look down here, you'll see that square corresponds to the second digit, we'll note that now as second, plus the third is equal to, less than, or more than 4. Let's go to the next clue. Either the difference between the first and second should be this one. Where is it? Here, absolute difference. First minus second. First minus third. Or second minus third is greater than 1. Let's do it again. Next one. First is less than, equal to, or more than 2. Number 1. Second minus the third. Keep in mind it takes the absolute difference. You see whether divisible or not divisible by 2. The number of 5s that appear in the code is a number between 0 to 3. So that would be this one. Oh wait, no. This one. And then the last one, second, is less than, equal to, or more than 2. Now that we have our 6 clues noted down, the thing that makes this module different from standard Turing machine is that in the module Turing machine, you are able to enter in 3 numbers and query it for a certain clue. The thing with this module is that you won't know for which of these clues you're querying it for. So if I input 111 and then query it, it could query it for the 4th clue or the 1st clue. You don't know. So the way we deduce this is through process of elimination. So I'll keep this here, and I'll actually replace every instance of first with A, second with B, and third with C, just to make it easier to understand. So the 3 digits here will just be A, B, and C. So let's just start off by querying a number. 111 querying to alpha. That resulted in a false, which, if you don't know, X means that the queried response was false, and an Oscar would mean that it's true. So let's just copy this and see which of these it could have been. So B plus C, these two, 1 plus 1 is 2. Less than, equal to, or more than 4. In what case would this rule be false? It would only be false if this were the case. No, wait, hold up. 2 less than 4. It'll only be false in this case. Or wait, no. My brain is short fusing. A moment. No, that will result in true. There you go. So basically what we just did is we removed which of these possible things it cannot be. Because if the actual expression were to be less than, then this rule would have to be true. But it isn't, therefore we just remove that less than symbol. Now let's see. The difference between two of these letters, which in this case is always going to be 0, is greater than 1. This, if you're creating all the same number, will never apply. So it can still be this rule because it resulted in false. Now we have alpha, the first value, less than, equal to, or more than 2. That would only result in false if either it was this or this. The fourth clue, b minus c, 0, is either divisible or not divisible by 2. It is divisible. 0 is divisible by 2, so it would only be false if it were this, not divisible, which that's how I'm noting it down. The number of 5s that appear in this sequence is 0, so it resulted in false, so it cannot be 0. And b is less than 2, and it results in false, so it cannot be this. And now we just create another number. What seems to be a good one? Let's do 131. String for alpha. It resulted in true. So, basically what had happened there is that changing the b variable changed it from a false to a true. So we know it can't be this rule because the alpha value stayed the same. We know it can be this rule because the number of 5s within these still is the same. This rule can apply. In which case it would have to be this. It cannot be this rule because the second minus the third is 2, which is divisible by 2, which this should always result in false if the difference is even, but it didn't. This rule, the second plus the third is 4, which is equal to 4. So it would have to be this. For this rule, either the first minus the second or the second minus the third is greater than 1. One of these two. Now, let's change it up a bit. Let's do 3, 1, 1. Actually, no, it's a 3, 1, 3. Keep in mind, you are not allowed to query the same 3-digit number again. So if I create 111 for A, I am not allowed to query it for any other clue. That doesn't mean, however, that we are not able to submit it. If I query 111 and the solution is 111, I'm still able to submit it. In the case that you do end up querying every single combination of numbers, it will reset back and you'll be allowed to use them again, I think. So yeah, now let's query 313. It results in false. Again, this module is very similar to the standard Turing machine, or if you don't do that module, probably Puzzword. Again, these modules are very similar. 313 resulted in false. So this would result in false. This stayed the same, but it resulted in false. So it cannot be this rule. And now let's see. This between A and B, that's 2. This between B and C, that's 2. This should always result in true. But it didn't, so it cannot be this rule. So using 3 queries, we have determined that alpha, so alpha, is this rule. B is greater than 2. Moving on to the next one. Move it to the top. There you go. Now let's query all B's. Well, let's query everything for Bravo. Let's do all 2s. False. So let's see what it would have to be. The second plus the third, that would be 4. This will only result in false in this case. I'm gonna skip over this one for now. The number of 5s is 0 and result in false, so it can possibly be this rule, it's just not 0. The second minus the third, absolute difference, is 0. It is divisible by 2 and result in false, so therefore it has to be not divisible by 2. A is equal to 2 and that result in false, so it cannot be that. Now this rule again. The difference is always 0 between these 3, so this is always false, so nothing changes there. Now let's do 2, 4, 2. Again, true. Same case as last time. Increasing this one changed the thing. So it cannot be this rule because the number of 5 stayed the same. Cannot be this one because alpha, the first value stayed the same. It cannot be this rule because the difference between these two numbers, the parity stayed the same. However, now B plus C would be 6, which is greater than 4. So it is possible for this rule to be this. Now let's check these. These 2's stay the same, so cannot be that because the statement changed the outcome. So it's possible for it to be either the difference between these 2 or these 2. Now let's query something that would end up solving this. I think no, I already did 1, 3, 1. 2, 4, 2. No, that'd be too much. Aha. 2, 3, 2 should do a trick. 2, 3, 2. Result in true. Now, let's see that here. The second plus the third would be 5, which is greater than 4. This stayed the same, so it could be this rule. However, now, the difference between the first and second, 1, or the difference between the second and third, also 1, is never greater than 1. So it cannot be this rule. Again, now we've deduced that this rule, B plus C, is greater than 4. That's our clue B. And we do this for every single clue until we have all of them, and then we deduce what the final submission number is, which is also a 3-digit number. Except we'll be using all of the clues. Okay, all 3's. True. Surprising. That helps us with this rule. The difference between all of these numbers again is 0. So this rule would never be true. Then you can also deduce this. That would have to be, it would have to be this, and it would have to be this. That helped us out a lot. Let's create something else to narrow it down to 1. Let's include a 5 in there to deal with this one. Yeah, 1, 5, 5, I think. Narrow down by 1 at least. False. Okay, so it could be this rule. This rule, it cannot be. This between the second and third is 0. This should result in true, but it didn't. And number 5 is 2. So this would result in false because we have 2 5's. So it can also be this rule. Now let's just do like extremely simple one, 3, 1, 1. True. So the number of 5s in this one and this one. Oh wait, no, it can still be it. Yeah, this helps us with nothing. Let's do 315. That should help us figure it out. There we go. 315 was all in the false. So the A value stayed the same here, yet the outcome changed. So it cannot be this one. And I changed just the number of 5s in the number, and this resulted in false. So this rule is that the number of 5s in the final number is 0. Now we have just these three. We're all 4s. Actually, if you end up querying a number that you've already queried, for example 111, it will just show up as red. There's no strike that happens, nothing. You just get like a warning sign that like you've already done this before. Let's query all 4s in delta. So that result in a false. This would mean that A cannot be greater than 2, the first number. This between these two numbers would have to be not divisible by 2, also known as they have to be odd. And the difference between these, this would always apply to be true. Now let's do 424. 424. True. It cannot be visible because it is between the two is even, and we've determined that this would have to be odd. And this rule, it also cannot apply because the A value stayed the same. So it has to be one of these. Again, like this. So now let's figure out whether or not it's this is between A and B or the difference between B and C, which we can do by just changing one of either A or C. 224. True. So this between A and B is 0, which would result in false. And this between 2 and 4 is 2, which is greater than 1, which would result in true. Meaning that this clue ends up being the second minus the third is greater than 1. This. Now just have these left. Let's create all 5 for the fifth one. That resulted in a true, which would mean that it have to be this or this. Oh wait, no, this. There we go. And now you can literally just change like the C variable to make the difference here odd and see if that changes anything. It did. From that, we can also now deduce that this is the rule. That the difference between the second and third number has to be even. And now let's just check the final rule. It just has to be this. Let's just see, is A greater than, yeah. Value A is not greater than 2. Is it equal to 2? It is equal to 2, because that's resulting in true. So, now we have 6 clues. Which I'll just move these down to here. There you go. So we now are going to be using these 6 clues that we've figured out what they actually are, because these screens only show possibilities of whether or not it's this, or this symbol. Now, we're going to figure out what the final submission number is that satisfies all of these rules. So I'll start off by just noting down like this. This is the first digit, the second digit, and the third digit. This rule tells us that there cannot be a single 5 anywhere. This rule tells us that value A has to be equal to 2 here. This rule tells us that value B has to be greater than 2. So it cannot be 2 nor 1. Otherwise, this rule will be false. Let's see here. The second minus the third has to be greater than 1. Meaning that if this were a 3 and this were a 3, this rule would be false. If this were a 3 and then a 2, or a 3 and a 4, or a 4 and a 3, this would also be false. Meaning that basically any case with the third digit being a 3 or a 4 would result in false. Meaning that it cannot be these two. Now, it can still be this 2 because value B can still be the 4. Now, let's see. B plus C is greater than 4. And also, B minus C is divisible by 2. So, this rule tells us that the second and third digits are either a pair of 3, 1 or 4, 2. So, 2, 3, 1 or 2, 4, 2. Let's check. 2, 3, 1. This between the second and third. 3 minus 1 is 2. It is greater. But, however, the second plus the third is 4, which is not greater than 4. Meaning that it cannot be this. And now if we check 2, 4, 2, if it satisfies all the rules, which it should, the second number is greater than 2. That's true. The second plus the third is greater than 4. That's also true. Number of 5s in this number is 0. That's true. The second minus the third is greater than 1. That's true. The second minus the third is divisible by 2. That's also true. And the first number is a 2. That's true. So now we just enter in 2, 4, 2. Wait, I wonder. Yeah, I've already queried 2, 4, 2, but I can still submit it by pressing this display here. Now it goes for all the rules, checking whether or not it's true or not. This module can also generate anywhere from 4 to 6 clues, so you're not going to be noting down this much every time. But yeah, that's Turing Machine Nightmare. If there's anything that I didn't really cover about like how this module works with all this clue generation, just check on the standard Turing Machine tutorial. I don't remember who does it, but they explain this in probably more detail than I do. I just cover how to solve the more crueler version that only has this one change. Anyways, that's it for this tutorial. I hope you enjoyed and that this helped out, and I'll see you all later.